Welcome audience to our opencappy course, and today with me I got a distinguished research staff member of IBM Austin, Dr. Peter Hofstee, who is also a professor at Technical University Delft, commonly known by TU Delft at Netherlands. So welcome Peter, and first of all let me thank you for designing the course of opencappy. So, so my first question to you, Peter, regarding opencappy. So regarding this course, maybe, I mean, why do we need this type of hardware acceleration when it comes to big data analysis?
Yeah, so in general, of course, you need acceleration to or accelerators to make computers better, right? And in one of the first modules, we look at what defines a better computer. So it can mean, you know, faster, more efficient, etc. And, you know, in the context of big data, of course, the challenge is that because of the internet and the various ways in which we can efficiently gather and store data, we have a lot of data to process. So it's especially interesting to process that data quickly and efficiently.
Oh, okay. So what is FPGA, by the way? So we are talking all about FPGA in the course and then opencappy. So what is FPGA and how is it different from, I mean, the high-performing CPU and GPU or other hardware?
Yeah, so FPGA stands for Field Programmable Gate Array. So it's also known as reconfigurable computing, right? So in an FPGA, typically what you do instead of creating a particular function by having a processor and programming it to do that function, you basically lay out that function in space, so in gates that are configured to do something, and they're actually, you know, little lookup tables and little storage elements called blockrams that are in the FPGA, and that has the advantage that you gain in efficiency. The data goes directly from one function to the next instead of having to go back to register files or memory. And it allows you to often create lower latency and more efficient solutions to a problem.
Okay, so well, so that's about FPGA. Thanks for the answer. So the question that immediately comes into my mind after learning about a little bit of FPGA, so why opencappy? I mean, how is this related to FPGA?
Yeah, so it's related to FPGAs and to accelerators in general, right? So typically, if you wanted to develop, and let's take the example of an FPGA, an accelerated function for a computer using an FPGA, you would have to put it on a PCI Express card. And the problem with that is that an accelerator on a PCI Express card does not have direct access to the memory of the host. So typically what you then end up doing is that the host computer has to do a bunch of work to get the data to the accelerator, copying it into a buffer that the accelerator can access, and then also on the way back. And, you know, if you dig into it a little bit more, and we do that in the second module, you'll see that the cost of doing that is even much higher than just those copy operations. The operating system tends to have to get involved, etc. So you can create much more efficient accelerators if you are able to provide them with memory access to the memory and other resources in the host, just the way any processor would be accessing it, and that's what opencappy provides.
Mm-hmm. Just one follow-up question regarding this. So how about the ease of programming? Let's say considering the GPU program or high-performing CPU program, parallelization, threads, and FPGA program. So which one is easier and in what way?
Yeah, I think even though there are tools now that can translate C to FPGA configurations. I think if you look at and therefore if you look at a kernel, creating a kernel for an FPGA may be more work, right, than it is for a GPU. But to go back to opencappy, I think the really important thing, especially if you look at large applications, is to be able to go into the middle of an application and say, okay, here's a function that is a good candidate for acceleration. Just lift that function out without having to change the whole data structure of the program, and just take that function and implement it on the FPGA. And with opencappy, you can easily do this because I can pass pointers to the FPGA. If I was going to do a procedure call, for example, I might have everything I need on the stack, and all I need to do is pass a pointer to the FPGA. And because it has full access to everything, it can then fetch what it needs and put things back. And as a program developer, as a programmer, I don't really have to worry if maybe somewhere in the middle that FPGA might have to reference something that I didn't think of before, because they can. It'd be just the same as a processor. So it becomes a much easier to integrate design. And if you have to maintain large pieces of code, this kind of thing becomes very important.
Okay, so yeah, I mean, that's a great answer, and thanks for explaining all these things, Peter. So the next question is, who are the user of opencappy, or let's say what type of analytic application or other type of applications can be benefited with this opencappy accelerator environment and FPGA and all these things? So if you can shed some light on that.
Yeah, so I give a few examples in the module 2B. The things that opencappy is useful for, the examples I give, I think, is compression, decompression, acceleration of text analytics functions, those kinds of things, and they are a good match for opencappy FPGAs for some of the reasons I mentioned earlier. Another quite interesting example is what is called thymesis flow, and it opencappy actually gives you a function where you can basically use a CPU as a router. And the way this works is you come in with a virtual address that the CPU, through its page table, is going to map to the physical address. But that physical address can again be mapped to a particular opencappy port. So now, based on the virtual address with which I come in, I might go out through one of a number of opencappy ports, and of course eventually hit memory. So I think that kind of thing is also a very interesting application. And in Power 10 processor, this is actually integrated in the hardware of the CPU itself.
Well, thanks a lot. So in order to just summarize this interview, as you can understand, the audience, so opencappy together with FPGA can not only handle the big amount of data, but it offers also some ease for programming to the big data analytic software developers also. And there are a broad range of applications that can be really benefited from this FPGA and opencappy. And as Peter mentioned, that IBM Power 10 is being launched recently, and it has opencappy embedded in that processor. So, well, this is a very good time to learn about the FPGA acceleration together with opencappy and collaborate with IBM and maybe develop some great application. So I'm pretty sure that in the next few modules, you will learn a lot about opencappy and FPGA related acceleration. So enjoy the course.